Chalo, keep reading. Elasticity. Elasticity. You already know the elastic properties which you know in the surroundings, mein. Like rubber and everything is a elastic property on that. Okay, to understand elasticity, we have to know some terminologies, two terminologies, that is deforming force. Deforming force means a force is said to be deforming force if it can change shape, size, and position of the object. Suppose I'm giving certain force, because of that force, size, shape, and everything will changing, means that is called deforming force. Okay, any object ko. So generally, solids are also having solids also will compress hoga, elongate hoga, even. Okay, so deforming force means if the force can change the shape, size, and position of the object. Next one is restoring force. Restoring force means already when I apply a deforming force, if I remove the deforming force, again it come back to the original position, like spring. If I apply deforming force, it will change the shape, size. When I remove the deforming force, again come back to the original position. That is called as कितना है? Restoring force. If the object, the restoring force, if it brings the object back to the original shape, size, and position after removal of deforming force, this is called as restoring force. देखो, he is applying the deforming force first initially when he's jumping. मतलब shape, size is changing. Okay, and when he's jumping again back, again is coming back to original position. That is called restoring force. Okay, restoring force की वजह से is coming back to original position. Elasticity.
Shevans, can
This is
you
the
go back?
yeah.
Okay, sure.
Okay. Next, elasticity. The chapter name वही है ना? The property of a body due to which it tries to regain its original configuration when the deforming forces are removed is called elasticity. एक rubber है. If I remove the deforming, an example, quartz, rubber, steel, iron, these all are elastic property. Rubber को, if I remove the deforming force, again come back to original position. This is called elasticity property. Done?
Sir.
Okay. Chalo. Now we have different elastic behavior of solids में देखो, normally solids का कैसा रहेगा मन में, every object has a elastic property. You will think that solids will not have elastic property. नहीं, ऐसे नहीं है. Like atoms, if you see inner structure of the solids में, atoms this ऐसा रहेगा. Okay, So that means every solid also have a elastic property, because if you compress, the springs are getting compressed. If I remove the deforming force,
So your video is getting frozen again.
this property called elasticity. This property we call as elasticity.
So our
Okay.
video is getting frozen and coming back.
Every time it's going again. I'll join. Wait. So, this property we call as elasticity, because every material has arms are. Okay. Anshuti, Hevala? Every property, every solid atoms are connected, and you can imagine like a spring. Force of attraction we call a spring. So when you apply, deforming force, the solids also little bit compression will be there always. Okay. This property we call as elasticity.
1 second, 1 second.
Yeah. Done. Okay. Sure. Now we'll talk majorly क्या है इस chapter में. We are studying about stress, strain and modulus of elasticity पढ़ने वाला है majorly. Okay.
Yeah, so done.
चलो. Elastic properties of solids. Okay. So in this में first one we are studying stress. Stress. So what is stress? Like exam stress, daily stress only, right, for you? What is stress? Stress is, देखो, we represent as sigma. Stress curve. The internal restoring force per unit area of cross section area of the deformed body is called as stress, and we represent as sigma. Okay. So what is saying? Suppose मान लो you have, देखो, internal restoring force per unit area. Suppose मान लो you have a conductor. You have a conductor. It is fixed and I am applying an external force like this. Is conductor को I am pulling with some force, external force. So वो क्या होगा? Every cross section को ऊपर there is a restoring force acting in the opposite direction. Restoring force acting in the opposite direction. So ऊपर restoring force is acting per unit area. That is called stress. Okay. And the stress at equilibrium में क्या होगा? At equilibrium में the external force is equal to restoring force. That's why whenever they say stress find karo bolto, what is the formula basically? Restoring force upon unit area, right? This
So
is
what
the
is
force
FE
acting per
again?
unit area. Huh?
What is FE?
External force. So this restoring force per unit area, right? And at equilibrium, restoring force and external force are equal. So therefore, F upon area. F upon area. So force upon area is called stress. That's it. Force upon area को we call as always stress. So inside वाला मत पकड़ो. External force 5 Newton दिया तो 5 Newtons per unit area is called stress. So every cross section के ऊपर there is a stress acting, and the stress formula is force upon unit area, and SI units are Newton per meter square. We call as Pascals also. So now we have different types of stresses. How you wrote exam? Krisha, exam हो गया आज अब इसका?
Sir, I didn't write.
Why?
Sir, I wasn't feeling well, so I didn't get up that morning.
Okay. आप प्रणव कैसा किया exam?
So paper 1 I did good. Paper 2 I
Okay.
did okay.
Okay. Advance का लिया क्या?
Yeah.
So double advance.
Double advance. Okay. चलो. Now we have different types of stress. One is longitudinal stress. Name itself indicating longitudinal means along lengthwise we are applying the force. At the time stress happens, that stress is called as longitudinal stress. And longitudinal stress is nothing but it is stress experienced by an object when a force is applied along its length. That's why longitudinal, along its length we are applying. At the time stress act over that is called longitudinal stress, causing to stretch or compress. में लगाने से क्या हो रहा है? स्ट्रेच भी हो सकते हैं और कंप्रेस भी हो सकती है. द स्ट्रेस इज कॉल्ड एज लॉन्गिट्यूडनल स्ट्रेस. एंड वी हैव, देखो मैं इसको elongate कर रहा हूं.
So video is stuck again.
Done?
1 second.
Yeah.
Yeah, so done.
Yes. Next. Now we have types of longitudinal stress. One is tensile stress. Tensile stress. देखो longitudinal stress produced along the due to increase in length of under ऐसा stress we are giving so that body को increase हो रहे. That type of stress is called as tensile stress. Okay. And tensile stress के वजह से देखो length of the object got increased to delta L. मान लो this is L, this is L पूरा, this is delta L. Okay. And the tensile stress का फॉर्मूला है restoring force upon area. Restoring force is nothing but external force only. Force upon area is called as tensile stress. Tensile stress क्या कर रहा है? जब सी दोनों है लॉन्गिट्यूड स्ट्रेस ओनली, जब फोर्स अप्लाई करूंगा द बॉडी का डायमेंशन आर इंक्रीजिंग सच. ओके, टेंसाइल स्ट्रेस. Next one is
So
compressive
1 second, sir. Can you go back for
stress.
1 second? So can you go back for
Yeah.
1 second?
So internet issue is there today.
Sir?
Yeah, today some internet issue is there. I don't know.
Yeah, sir. Now done. So you can go to the next.
Next one is compressive stress. Compressive stress क्या करेगा? ये भी longitudinal stress only. The force मैं apply कर रहा हूँ so that it will compress. It will make the body to shorter. देखो, उसमें मैं force apply करूँगा, the body का थोड़ा कम हो जाएगा, length कम होगा. Such type of stress acting at that time is called as compressive stress. And compressive stress का formula क्या है? Force upon area. खत्म. Stress का always force upon area. This is called compressive stress. Stress always will represent as sigma. So both we are applying along the length only. That's why it is called long stress. Both.
Done, sir.
Done?
Yeah.
Okay. Chalo. These are the types of stresses. करो. Stress find करो. So find stress. A steel wire having radius is given, carrying a load this much, is hanging a ceiling. Given G value they told us 3.15 meters per second square. What is the tensile stress that could be developed in the wire? Find करो. J means question.
Sir, a steel wire is cylindrical in shape.
Sir,
Always 5
3.1 into 10 power 6.
So, sir, I have to wait, never mind.
So 3.1 into 10 power 6.
Sir, 1 second.
Yeah, let them do. Let him do.
Yeah, 3.1 into 10 power 6.
Yes. Next one करो. The system is released, M is 2M, capital M, then stress produced by the wire is how much? In terms of variables, may is asking the options.
So the restoring force will be the same as the tension, right?
Yes, because external force and restoring force are same in all questions in your portion.
So you cannot directly use the tension formula.
Use whatever you want to do. Use J means 2013. So this is force upon area.
So the thing is, I forgot the formula.
Hmm.
Isn't
Recently you
it?
told you
It's not m2 minus m1 by
there
m2
is
plus.
acceleration.
Yeah. It's like 2m1 m2 by m1 plus
M1 plus M2 into G.
Okay. So that's 2 that's 4m by 4m square by 3. So 4mg by 3a. Option B.
देखें टेंशन का शॉर्टकट फॉर्मूला यूज करो 2m1 m2 by m1 plus m2 into G.
Sir, sir, what do we do after finding tension?
Whenever pulley is attached with two masses, टेंशन का फॉर्मूला यूज करके वो करो.
Sir, what do we do after finding tension?
Stress is force upon area, right?
Hmm.
फोर्स का कितना है? फोर्स इज नथिंग बट टेंशन ओनली. इसके ऊपर फोर्स फाइंड करो, टेंशन बाई एरिया करो, आ जाएगा.
Oh, just okay.
गॉट
Yes, sir.
कितना?
So 4 mg by 3a.
See, they given mass also, right? M equal to m बोल के question यूज करो and get the answer. Okay, 2m1 m2 by m1 plus m2 into G is the formula. Upon area क्या तो आएगा 4mg by 3a is the answer. वो लिख लो. Next will be second type of stress we call as shear stress or tangential stress. Shear stress or tangential stress. Shear stress क्या है? Because stress is said to be tangential if the deforming force is acting direction of the area of cross section. मतलब tangentially the force is acting. It is changes the position of the object. Suppose मान लो block is there. Okay, I applied a force tangentially. I am applying tangential force to the area of cross section. इसका लेंथ इज L मान लो. ओके, थोड़ा क्या होगा, थोड़ा स्लाइटली थोड़ा बेंड होगा, ऐसा बेंड होगा. ओके, दैट मतलब shear tangential stress, tangentially we are applying that type of stress is called as shear stress. मान लो ये ओरिजिनल पोजीशन था, x डिस्टेंस घुमा है एंड इसका लेंथ है L मान लो. ओके, एंड दिस इज एंगल थीटा. कितना घुमा है? थीटा. ओके, नाउ देखो एग्जांपल में द बुक का, इफ यू आई एम अप्लाइंग tangentially, देखो थोड़ा बेंड होगा ना, थोड़ा बेंड होगा. That time that stress is called as shear stress. That stress is called as shear stress. देखो कितना x घुमा है, थीटा थीटा एंगल घुमा है एंड लेंथ है. ये आपको स्ट्रेन में यूज होगा दिस वेरिएबल्स. बट इसका फॉर्मूला क्या है? shear stress का फॉर्मूला इज tangential force upon unit area is called as shear stress. Tangential force, all are force upon area only, कुछ नहीं. इसमें tangential force upon area.
Yeah, so done.
इसमें इम्पोर्टेंट थिंग क्या है आपको, यंग्स मॉडल्स ऑफ इलास्टिसिटी वाला बहुत सारा क्वेश्चन रहेगा, उसी में ज्यादा क्वेश्चन आएगा.
So why is there a force acting in the downward part of the block?
नहीं नहीं ऐसा नहीं, मतलब फ्रिक्शन जैसा एक्ट बट दिखा है, बट जनरली क्या है आपको फोर्स, टेंजेंशियल फोर्स वी आर टॉकिंग अबाउट, दिस फोर्स अपॉन एरिया इज कॉल्ड एज, ये पूरा बंद है ना, पूरा क्लोज है, सो सम बॉटम का फोर्स आल्सो एक्टिंग बोल के दिखा है, बट आपको ये
Okay,
वाला
sir.
कॉन्सेप्ट, टेंजेंशियल फोर्स अपॉन यूनिट एरिया इज कॉल्ड एज shear stress. Okay. Now, sun is
Sir, one
immersed
minute.
in the fluid.
Sir, can you show the diagram again? Okay, sir.
Okay. Volume stress or bulk stress. If the object is immersed in a fluid at rest, the fluid exerts a surface of the object. Acts, the force always acts perpendicular to the surface बोल के we assume, right, in fluids में. So उसके वजह से the volume get decreased. The volume of the cube get decreased. Okay. The time stress is happening. That stress is called as bulk stress or volume stress. एंड बल्क स्ट्रेस और वॉल्यूम स्ट्रेस का फॉर्मूला देखो, फोर्स परपेंडिकुलर ऑलवेज, फ्लो फोर्स विल बी ऑलवेज परपेंडिकुलर टू द ऑब्जेक्ट. ओके, सो फॉर्मूला क्या है इसका, सिग्मा वी इज इक्वल टू फोर्स, परपेंडिकुलर फोर्स अपॉन एरिया, एंड इसी को वी कॉल्ड एज प्रेशर, और दैट इज इक्वल टू वी कैन कॉल डेल्टा पी, चेंज इन प्रेशर. We can replace this force, perpendicular force upon area को in this में we can replace as delta p or p. Delta p is a change in pressure. Okay. So क्या है, any object को when I put in water, because of force which is acting perpendicular to the cross section area, because of that force the block का size will decrease. Some stress is happening in the object. That stress is nothing but force upon unit area. And इसमें we call as delta p or p. इनसाइड प्रेशर है तो डेल्टा पी बोलते हैं. Done?
1 second. Yeah, so done.
चलो, now we'll go for strain. Okay, stresses we learn, right? Strain का we learn now. Strain का. Okay, strain क्या है? Dependent change in configuration by original configuration is called as strain. Strain का symbol है ऐसा E. Configuration means it can be changed length, volume, angle, anything it can change. Okay, change in configuration by original configuration. And इसका पास units are no units because दोनों same quantity, length, volume ऐसा रहेगा ना. So that's why we have no units in this strain में. Change in configuration by original configuration per unit original configuration is called as strain. Strain का symbol है ऐसा E जैसा.
Yeah, so done.
Okay, चलो. Now here also we have three types of strains. कौन सा tell me? Same names. कौन सा है? Longitudinal strain, volume strain, shear strain. खत्म. Three types of strains are there. Okay. So लिखो.
So wait, so the symbol of strain is E.
Type of strain is called as longitudinal strain. Longitudinal strain समझ में आया? Change in length by
So
original length.
what's the symbol of strain again? E. Yeah.
E ऐसा. Okay. And first one is longitudinal strain है delta L by L. खत्म. That is called as strain. E is equal to delta L by L. This is called as longitudinal strain.
Yeah, so done.
Done ना?
Yeah.
Yes. Next one. Next one is volumetric strain. Volumetric strain क्या है? It is defined as change in volume by original volume. And change in volume, a volumetric strain should be positive है ना? Change in volume will be negative. Minus of minus will be plus हो बोल के minus लगाया. Minus is minus क्यों लगाया? Because strain should be positive in this, right? So formula क्या है आपको? देखो, original volume is there. पानी में डुबाने से आपको वॉल्यूम चेंज हुआ ना, सम वॉल्यूम चेंज, दैट चेंज बाय ओरिजिनल वॉल्यूम इज कॉल्ड एज वॉल्यूमेट्रिक स्ट्रेन. दिस इज द सिंबल minus delta V by V. This is a volumetric strain. Easier. Stress three types, strain three types. Done?
Yeah.
Yes. Next one is shear strain. Shear strain क्या है आपको? देखो, डिफाइंड एज एंगल थ्रू विच द ऑब्जेक्ट इज sheared by the application of tangential stress. I am applying a tangential stress. कितना एंगल घुमा है? That is nothing but shear strain. देखो, initially I told right, ये applying tangential force, ये x distance घुमा है, ये original length L है and theta है. Okay. So what is tan theta is in this right angle triangle model tan theta? Opposite by adjacent. Opposite by adjacent, right? And shear strain is what? X by L को we call as shear strain. And whenever theta is small, we should replace tan theta को theta replace करने वाला है. Shear strain है. Now therefore आपको what is the आ गया copy it first. So therefore stress का फॉर्मूला क्या है? Strain का फॉर्मूला क्या है इधर? Tan theta is equal to X by L. Nothing but shear strain. That's why I told you X and L is important. बोल के theta is nothing but X by L.
Yeah, so done.
Chalo. Now we done three types of stresses, three types of strains. Simple है, right? Stresses का all formulas are force upon area only. But you have to apply. We have to know which direction the force is applying. आपको JEE मेंस क्वेश्चन में theoretical क्वेश्चन भी पूछ रहा है. Directly a tangent similar strain also three types: longitudinal strain, shear strain, and volumetric strain. Right? Circle. Fine. Without copying करो. A steel wire 2 meters long here, suspended from ceiling. When a mass is hung in the lower end, the increase in length is recorded as much. Determine the strain.
So
Strain मालूम है?
0.005.
0.005.
So 0.01 by 2, yeah, 0.005.
हाँ. हो गया. नेक्स्ट करो. Who's determine the stretching force of the second cable? Force चाहिए. दोनों have the same stress. Calculate.
So 570
Yes,
approx.
So one
on the
second.
video. दोनों में स्ट्रेस इज सेम. फोर्स अपन एरिया इक्वेट करो, आ जाएगा.
So like, will you get an exact value or an approximate value?
एग्जैक्ट पे जा रहा है.
So how do you know stress is same for both?
अरे वो मतलब कितना फोर्स लगा है तो स्ट्रेस इज फोर्स अपन एरिया, राइट. एरिया का चेंजिंग, फोर्स विल बी
Is
सेम,
it
राइट.
570?
हाँ, 570 इज आंसर.
Okay.
सी दोनों में इसमें क्या है, रेडियस इज चेंजिंग, राइट. बट फोर्स में भी डिफरेंट, राइट. सच दैट द स्ट्रेस इज सेम. Okay, just equate but both force upon area will get 570 is answer. Next. Weight is nothing but forces only. If there are cross section areas are given to you, then which is a stronger material? मतलब ज्यादा स्ट्रेस है, किसका ज्यादा है, वो स्ट्रॉन्गर है.
Okay, the first one is stronger.
Why?
It has more stress.
Yes. Yeah.
Yeah.
Okay. Next. Michael. A die is designed to punch holes with a radius this much, metal sheet of this much thickness, okay, shown in figure. The punch through the sheet, the die must exert a shearing stress this much. What force must be applied? उतना स्ट्रेस आने के लिए कितना फोर्स अप्लाई करना पड़ेगा? force sigma is equal to force upon area, force equal to sigma into area. एरिया कौन सा यूज करेगा? ये थिकनेस भी दिया ना, द एरिया
Yeah.
ऑफ कंप्लीट लाइक सिलेंडर जैसे यूज करने का एरिया कौन सा है, 2 pi r into the thickness, that is the area.
So why into thickness?
Because they told to punch the sheet, to punch the sheet the die must exert a shearing stress of this much, what force must be applied to the die, ये पूरा शीट
Oh,
निकलने का
oh,
right?
oh, oh, no, man, understood. Sir, I used calculator and I got answer as 6.6 into 10 power 7.
6.6 in 10 power of 7
Yeah.
थोड़ा आगे.
Sir, you have to do volume, right?
हाँ वॉल्यूम लाइक यू नो एरिया कैसा है, मतलब 2 pi r into the thickness करके
Yeah.
वॉल्यूम करके.
Sir,
How much?
sir, 66.
66. 6.6 into 10 power of 4 r. Okay. So calculation में देखो, but better समझो, force is equal to sigma into area. वो calculate करने का will get as 6.6 into 10 to the power of 4 newtons. Okay.
Sir,
Yeah, tell me.
sir, we only have to convert the thickness into meters, right?
Thickness कितना दिया? 3 in 10 power of -3. Oh, yeah. Yes, correct only. Yours correct only. 66, right? Okay. So ये नहीं है because meters बोल के दिया है. अगर meters है तो कितना आएगा? Tell me. अगर meters है तो ये आंसर आएगा, देखो 6.6 into 10 power of 4 आएगा. ओके चलो नेक्स्ट मैं करो. Length of the wire is 2.5 meters. Percentage strain is 0.012 under the tensile force. The extension produced by the wire will be. Delta L is asking. The given strain percentage.
Won't just be 0.01. One second. Don't just be 0.012 divided by 100 into 2.5.
So it'll be 1.2 divided by 2.5, right?
See, strain, देखो, indirectly what is the strain means what, which was delta L by L into
Yeah.
100, right? This
Yeah.
is percentage, right? Percentage is given as 0.012. That's it.
You'll get
Yes, it is.
0.003 meters.
Answer
0. No, you'll get 0.3 millimeters.
देखेंगे. Let them know.
Sir, yeah, I got that. 0.003.
Yeah, 0.3 millimeters आएगा आंसर.
Oh, sir, I thought it was in meters.
Yeah. आया कृष्ण. Next. If the angle of shear is 30 degrees from the cubical body, the change in position is given as 100 root 3. Change in position is the x value is given 100 root 3. Then what must be volume of the cube? L आने के बाद you can find volume.
So LS 300. Oh, 4 by 3 pi into 300 whole cube.
Wrong. This is shear के बारे में बात कर रहा. Shear stress, shear strain का देखो. Hundred root 3 is the x value.
So how do you know if it's X or L?
See, change in position. Change in position is when applying tangential force ऊपर में, the change in position is always x. Okay.
Oh.
The cubical length is nothing but length of the body is nothing but L.
Sir,
Side
2.7 into 10 to the power 7.
कितना?
2.7 into 10 to the power 7.
Okay. In meter cube में answer.
So 27.
Okay.
Yeah, 27.
Oh wait,
27.
cubical. Oh my god, it's L cube. Oh yeah, get 27 meter cube.
Yes, 27 is answer. समझ आ रहा है?
So answer is in meter cube or
मीटर क्यूब, मीटर क्यूब.
okay.
Okay, ये करो. A uniform cube is subjected to the volume compression. Volume compression किया है. Each side is decreased by 1%. The bulk strain is how much? Each strain is decreased by, each side is decreased by 2%. The bulk strain is how much? Bulk strain is delta V by V I want. देखो, whenever percentage is lesser than 5, you can use error analysis method use करके try करो. Okay. So what is the bulk strain है? Bulk strain का formula क्या है? Bulk strain का formula is delta V by V, right?
Minus delta V by
Minus
V.
delta V by, ठीक है.
So
वो
if I
find
do
करने
air measurement, if I take the new length as like L or something, you get that
देखो,
is equals to
yes. So V is equal to A cube is a formula for volume of the cube. I want error analysis में delta V by V into 100 is equal to 3 into delta A by A into 100. याद है वाला error analysis? And they given what each side is decreased by 1%. मतलब meaning क्या है? What is given? Volume percentage I want. Each side is मतलब इसका percentage is 1, right? Delta
yes.
A by A is 1, right?
Yeah.
Yeah, percentage. So 3 into 1 is how much? Percentage is
3%.
3. That's it. So it is
Oh, 3 is the answer. Oh,
3 into 1%. Delta V by V into 100. But 100 को भेजो उधर तरफ कितना होगा? 3 by 100. It is 0.03. This is strain, right? Delta V by V चाहिए. इसलिए 100 को उधर भेज दिया. Whenever the percentage is less than 5%, always use error analysis method. Done?
yeah.
करो. ठीक है. इसका हम लोग नेक्स्ट में करने वाला है पूरा.
Sir,
So
now
आपको we left with only